Welcome to this lesson on solving and writing addition equations. Please make sure you have these notes in front of you so we can begin our lesson. This lesson has two learning objectives. The first one says I can solve a one-step addition equation, and the second one says I can write a one-step addition equation. So let's go ahead and talk about some of our key concepts. The inverse of addition, and the word inverse means opposite, is subtraction. So the inverse of addition is subtraction. Whenever we're solving equations, the overall goal is to isolate your variable or get your variable by itself. In order to do that, we need to use the subtraction property of equality to balance equations. So speaking of balancing, let's take a look at this scale. I want you to think of the center of this scale as the equal sign. We also call this the fulcrum. So to make sure that our scale is balanced, we have to make sure that equal amounts of objects are on both sides of this scale. So right now, this scale is balanced because both sides each have 2 blocks. But if I was to take 2 blocks off of one side, the scale is no longer balanced. But in order to balance it, I would have to make sure that I take off 2 blocks from the other side as well. So now that I did that, my equation or my scale is balanced. So this is an example of the subtraction property of equality because I subtracted 2 blocks from each side of my scale, which makes my equation balance, or which makes my scale balance. So let's use these key concepts to discuss the following examples. Example 1 says solve a plus 15 equals 26. Then it says check your solution. So here's the problem. The first thing I want to do is I want to go ahead and draw a dashed line down the center of my equal sign because that's going to show where the fulcrum of our equation is. Now we have 2 sides. We have one side that has a variable and we have one side that does not. Let's always start on the side that has a variable. And the goal is to get the variable, or a, all by itself. So right next to a, I've got a constant of positive 15. In order to get rid of that constant so that a could be by itself, or we can isolate a, we need to get rid of positive 15. In order to do that, let's subtract 15. Let's do the opposite of addition and subtract 15. But right now my equation is not balanced. So we have to make sure we subtract 15 on the other side as well to keep our equation balanced. This is an example of the subtraction property of equality. Now on the left side of our equation, 15 minus 15 just goes away and we can drop down a. So now a has been isolated. And let's go ahead and subtract 26 minus 15 on the right hand side to get 11. So the value of a is equal to 11. So let's check our solution. Let's plug it back into the equation. So the value of a is equal to 11. So 11 plus 15. So when we do the math, we get 26. So we've checked our solution. So now let's go ahead and graph this solution on a number line. I'm going to start this number line by placing 0 in the middle. And I'm going to graph positive 11 on the positive side on my number line. So positive 11 is someplace around here. Let's call that 11, and we're going to identify it with a solid dot, because that is the only number that would make this equation true. For example 2, it says solve 8 equals 3 plus x, and then we can check our solution. So let's go ahead and draw our fulcrum down the center of our equal sign. And in this case, I'm going to start on the side that has the variable. In this case, the variable is on the right-hand side of my equation. In order to isolate x, I need to get rid of that constant of positive 3. So in order to get rid of positive 3, we have to do the opposite of addition, or positive, and subtract. So I'm going to minus 3 here. But I'll have to make my equation balance, so I'm going to have to subtract 3 on the other side as well. This is an example of the subtraction property of equality, because we subtracted 3 on both sides. So on the right hand side, I can go ahead and cross out 3 minus 3, because 3 minus 3 just becomes 0. And now x can be dropped down, and I have just isolated x. X is all by itself. On the left hand side, I can do 8 minus 3, which is 5. So the value of x is equal to 5. I can check my answer by plugging it back in. So 5 plus 3 does equal 8. So I checked my work. So now let's graph this solution on a number line. Let's start with 0 in the center, and since our answer is positive 5, I'm going to go to the positive region and identify positive 5 right here, and I'm going to identify it with a solid circle because that is the only number that can make this equation true. So pause the video and complete these got it problems, and we'll discuss the answer in class tomorrow. Notice I have got it problem A and got it problem B on the slide. And please make sure we graph your solution on a number line. For example 3, it says Ruben and Tariq have 245.5 downloaded minutes of music. If Ruben has 132 minutes, how many belong to Tariq? Write and solve an addition equation to find out how many minutes belong to Tariq. So the first thing we want to do is we want to identify some variables. R will stand for Ruben and T will stand for Tariq. So I can start my equation by saying Ruben plus Tariq equals total downloaded minutes. This problem tells us the total downloaded minutes, which is 245.5 minutes. And they also tell us that 132 belong to Ruben. Our job is to figure out the value of Tariq's minutes. So now that we wrote this equation, we can use this equation to solve for Tariq's minutes. So let's go ahead and draw the fulcrum down the center of the equal sign. And let's start on the side with the variable, which is the left-hand side. And let's isolate the variable by getting rid of that 132, the constant. In order to get rid of the 132, we have to subtract it on both sides. This is using the subtraction property of equality to keep the equations balanced. So once I've done that, I can cross out the 132, and we can drop down the value of t. And when I subtract 245.5 minus 132, I get 113.5. So this means 113.5 minutes belong to Tariq. So pause the video and complete this got it problem, and we'll discuss the answer in class tomorrow. Notice it wants you to write an equation for this problem and be sure to solve the equation. So for example 4, it says write an equation for the figure below. So before we do that, let's introduce you to a straight line. And this straight line, the total degrees of this straight line is worth 180 degrees. This is known as a supplementary angle. Any supplementary angle has a straight line, and the angle is worth 180 degrees. So if you take a look at our figure, we have a nice straight line. So we have a supplementary angle. All supplementary angles are equal to 180 degrees. So let's go ahead and write an equation for this figure. We have the value of x, which we don't know, plus 60 degrees. And when we add them together, it should equal 180 degrees because this is a supplementary angle. Now that we wrote our equation, we can solve our equation by using the steps that we've learned in the other example. So let's draw our fulcrum here. Let's start on the side that has the variable. And in order to isolate the variable, we have to go after the constant, which is positive 60. So let's subtract 60 on both sides. And by subtracting it on both sides, I'm using the subtraction property of equality. So 60 minus 60 goes away, and now x is all by itself, which was our goal. And on the right-hand side, we can go ahead and subtract 180 minus 60, and 180 minus 60 is equal to 120. So the missing angle is equal to 120 degrees. For example 5, it says write an equation for the figure below. So the figure below looks like a L shape, and the angle is a right angle. This is known as a complementary angle. And complementary angles have angles that are worth 90 degrees. So if we refer back to the figure, notice we have an angle that is complementary, and they have the 90-degree box in the corner. So I'm going to write an equation by writing 65 plus x has to equal 90 degrees because this is a complementary angle. So what we can do now is we can go ahead and draw our fulcrum down the equal sign. And let's start on the left-hand side because that's where our variable is. But in order to get our variable by itself, we need to get rid of that positive 65. So in order to do that, let's subtract 65 on both sides. And by subtracting it on both sides, we are using the subtraction property of equality. So I can cross out 65 minus 65 goes away, and I can drop down the value of x. And on the right hand side, I can subtract 90 minus 65 to get 25. So the missing angle is 25 degrees. So pause the video, complete these got it problems, and we'll discuss the answers in class tomorrow. Notice I have two got it problems on this slide, got it problem D and got it problem E. So now that we've completed this lesson, we want you to self-rate yourself and let us know how you feel. If there's any part of this lesson that you do not understand, please go back and watch the video again. Also come to class with some questions so we can discuss this in further detail.